All right. Hey, folks. Emily here, Principal Machine Learning Specialist Solutions Architect at Amazon Web Services. And today, we're going to learn how to prepare data and train at scale. So in particular, this is a part of our larger YouTube course on Generative AI Foundations on AWS. And in the last video, you got a taste of creating foundation models and pre-training foundation models from scratch. We learned about distributed training optimizations. We introduced something called data parallel, something called model parallel. We learned about this cluster concept that you can create all these things, but how do we actually do it? And so that's what we're going to learn about in this session. So let's get rolling. All right. So in particular, the first thing we're going to learn about today is how to prepare data at scale on AWS. And you'll notice there are many ways of doing this. We'll suggest just a couple of them. And a lot of them really focus on making CPUs do a lot of the work. CPUs are a tiny fraction of the cost of accelerators, particularly a tiny fraction of the cost of GPUs. So I would strongly suggest that you use CPUs as much as you can. And we'll talk about what it means to hydrate your training loop, right? You want to get to this point where your forward and your backward pass is running really nicely in PyTorch or however you have it implemented. And so basically we want to hydrate that with data. And so we're going to work backwards from that to figure out how to get you this. We'll look about distributed file systems, in particular FSX for Lustre, setting this up, configuring it, getting it to work nicely. We'll learn about warm pools on SageMaker training and troubleshooting, and then we'll close out with a hands-on walkthrough of creating SageMaker warm pools and then running them with FSX for Lustre. All right, so ideally, data preparation should be these things. Like when you're picking data preparation solutions, obviously you're going to want to pick one that's not expensive. You want to save money and not lose money on data, so low cost. You want data preparation to be somewhat simple, which is to say you want the amount of work that you have to do to manage this thing and provision it. You want that to be low. So you want the work itself that's necessary should be somewhat simple. You want your data preparation to be scalable. So you want to easily start from, hey, I have just a small sample of data to process, to now I have multiple terabytes and maybe I have multiple petabytes. So you want this ability to scale upwards, but then to scale back down when it's not necessary. So that core elasticity that you get with the cloud is super valuable. So we want that scalability and that elasticity. You want your data prep to be reliable. Like you want this thing to not go down. You want to be able to trust it. You want to know that when you hit it from n number of ways, it's still going to be there. So you want a reliable data store. You want data preparation to be usable. Like it should have good usability. Like the user experience should be fun, should be enticing, should be easy, should be intuitive. And then you want data prep to be easy to manage. So you want all of it to be straightforward and simple and intuitive and easy to track it and to manage it. So you have a ton of ways to do this on AWS. There are many, many different data preparation options on AWS. For the purposes of time, I am just going to laser focus on these top four. So we're going to look at S3 buckets. We're going to look at storing images in ECR. We're going to create FSX for Lustre, and we're going to use SageMaker. But that being said, I mean, again, there are a lot of really good options, and you might end up using those options for when you're storing even larger data sets, such as with Redshift. If you're creating a data catalog, such as with Glue, if you're running EMR processing with Amazon EMR, if you're just spinning up instances, if you're storing in DynamoDB, in Aurora or Athena, if you're creating a dashboard. So you have, again, a lot of options for data prep on AWS. And I'm just going to laser focus in on these four, but the other ones are really awesome. All right, so how are we going to do this? Our steps. So again, step one is just identify and store your data. Park that in your S3 bucket. Make sure you have data in S3, which Sometimes it's harder than it sounds, but other times it's as easy as I'm just going to upload the thing or I'm just going to do a copy. So nice and straightforward. So you've got data in S3. I always start with collecting like a tiny sample of this. So I'll spin up a notebook on some CPUs. I'll, just load pandas, just point to a small sample of this data set, run some analysis in pandas just to get a good understanding of what this data set looks like. After that, then we're going to create a distributed file system. So in particular, we'll use FSX for Lustre, and you're going to learn how to do that in this video. You're going to create an FSX for Lustre volume with all of this data. So the reason we're going to do this is that copying data is very, very slow and is very error prone. And not every use case is well solved by data streaming. Particular neural network optimization is quite challenging to write with streaming. And you still might encounter the case where everyone is pointing to the same, where all of your accelerators are pointing to the same files, which then causes read conflict. So in any case, distributed file systems are a great way to take one piece of data, one object, or terabytes of objects, park those in a single spot, and then scale throughput actually as a function of all of your accelerators. So you can have one object or one set of data with n number of mounts. So there will be actually as many mounts as there are accelerators, and the whole thing sort of scales with this entire process. So it's much easier to interact with when you're running a large-scale distributed system. So once you have your distributed file system built, I love using warm pools. Warm pools on SageMaker is so nice. Basically, you're running training jobs, and then you add this one parameter. Keep alive period in seconds is the name of this parameter. And then you'll run these new training jobs where the instances just stay warm. So as you run new scripts, the instances are still alive. And so they're perfect for developing and testing, because as you're iterating through your cycle, the instance is just literally still there. And so you can ship a new line of code in seconds, and it's beautiful. So manage worm pools. And so you'll run manage worm pools on your FSX for Lustre volume to develop this training script. And then once it's developed, then again, you'll scale up those training and processing runs. So you'll go from just what we proposed last time in the phases. You'll do your first run with like 1 GPU or 1 accelerator, then you'll move up to 8, then you'll move up to 2 nodes, then maybe you'll move up to 16 nodes or 64 nodes or however large you want to go. And then at each phase, again, you're just evaluating that model artifact and downloading it so that you know you can trust it and then it's working. So let's learn how to do this. All right, so step 1, obviously S3 is great. Let's be real, S3 is really good, right? You can upload data in S3, you can do it in the web browser, you can do it with your SDK, you can do it with your CLI, you can do it with an API, you can download straight to S3 when you're doing web scraping or if you're doing any other large-scale data processing. Tons of features for management, for security, access control. S3 is, so we call this 11 nines of durability. So that means 99 point, and then 9 more of these things, is how durable S3 is. So you're going to be able to get your files in a year with a tiny, tiny, tiny moment of downtime. And also what's nice about S3 is you do not need to provision a thing. Like the user experience is so on point with S3 because you just create a bucket. You can put literally as much data in this bucket as you want to, and there is no end. Like you can put as much data volume in S3 as you want to. You don't have to provision anything. You don't have to manage instances. You don't have to like lifecycle a piece. You just drop it in S3 and it's happy. So step 1 is get your S3 bucket online, create that thing, get your data loaded into S3. And then, yeah, we're going to mount a distributed file system. So the distributed file system is going to read from S3. So it's going to read from S3. The processing jobs and the training jobs can run here. And then when you write to Lustre, when you enable the two-way replication, it'll copy it back to S3. So it's really nice. And then for your data processing, you can do your data processing straight from S3 as well. You could like do your data processing to Lustre. It depends on if you already have it created or not. Once you have Lustre created, then and you have this two-way data repository created, then the two are kind of interchangeable. You just need to make sure that once you have something written to one place, that the replication job has happened, which should be automatic. But yeah, so you can run processing jobs and point those to S3, whatever works for you. So step one is just getting your data stored. Step two, again, is we're going to sample our data set and we're going to analyze that thing. So again, I like to start with my data in S3. I'll store a sample of data in S3, and then I'm going to pull a small sample from that thing. So I'll pull my 1%, my 2% data sample, something really small, and I'll just pop it on my notebook. Again, notebooks, you can run those on your laptops. You can run those on SageMaker instances. You can run those on other instances. It's completely up to you. Notebooks are great. As Brian Granger, co-founder of Jupyter, who's a senior principal technologist at SageMaker, he likes to say that the primary verb that we use to describe Jupyter notebooks is to think. Like Jupyter notebooks are here to help you think, actually, more than anything. So you can use a notebook to test a couple lines of code and analyze and assess and understand what your data set is, why it's composed that way, what to do. So you can run your notebook on your small data sample using SageMaker or using any instance. Again, I'm going to run Python code there to just understand and inspect my data set. You can detect bias in your data sets. You can work with small model versions. You might do some prompt engineering. You might do some lightweight fine-tuning. And you can also use this new @remote decorator to scale. So for SageMaker, as of a couple months ago, you can add this @remote decorator to local functions. And those will actually run on training jobs. So we'll actually like look at your configuration and then run a SageMaker training job in the back end taking this function. So definitely you could use that here. So that's step two, is we sample and we analyze. And then step three is we're going to actually create a distributed file system. So in the AWS console, my go-to way of doing this, I'll just go to the Lustre console page and click create an FSX for Lustre volume. Lustre will prompt you for what's called a VPC, a virtual private cloud. If you're new to this, you can just use the default VPC. Every account ships with the default VPC, so feel free to use that. Otherwise, you may have like a specific VPC with specific subnets and availability zones with capacity. So yeah, definitely something to consider. But in any case, you'll create your FSX for Lustre volume. While you're creating this volume, you're going to point to an S3 bucket, actually. So you can point to an S3 bucket that, again, has all of your data stored. So this might have your 2 terabytes of text files or your 200 terabytes of image files, whichever way you feel. And then, yeah, when you enable this two-way data repository, there will be a connection that's established between FSX for Lustre and your bucket. And this is a two-way data repository. So as new files are written to S3, these are automatically replicated to Lustre. And then the second way is the reverse. So as you, for example, write model checkpoints to Lustre, those will then be sent back to S3 and they'll be made available. So it has that really nice two-way replication. Great. And so then once you have Lustre set, you can actually mount this Lustre volume to a notebook. So you could mount that to a SageMaker notebook instance, for example, just as long as that notebook instance is in the same VPC. So you want to make sure that it's in the same VPC. You might do this in the same subnet, and then just make sure that the two pieces can talk to each other. Go get some routing friends to help you stand this up. Yeah, there are a couple pro tips to connect these two things. But so in any case, you'll get your notebook stood up. You can mount the Lustre volume and then analyze it right there. Using SageMaker is really nice for this as well because it's very easy to move up to a bigger instance. So for your notebook instance, you can turn the thing off and then recreate it with a larger volume. Or alternatively, you can use SageMaker Studio, which just lets you click a button and then switch out to a larger instance type. So it's really nice. So a couple pro tips for using FSX for Lustre. Again, it just takes a couple minutes to create FSX for Lustre in the console. And then, yeah, just follow guides to do this in your preferred VPC. Make sure you're tracking your security groups, your ACLs, things like this. One word of caution here is Lustre is going to copy all of the file names onto the mount. So the mount here, the volume, is going to have all of the file names. You need to actually run a CPU-based job to read all of those. It doesn't have to literally be CPU. It's just a lot more cost-effective to do this. So you run a CPU job to read all of those. When you read it, Lustre will manage the copy, and then the file sits there. And then the read is scalable with all of your accelerators. So definitely something to note. Yeah, and then you can mount the volume from the notebook in your same VPC to test. So that's how to create a distributed file system, such as FSX for Lustre, and then mount a notebook to this to test it and analyze your data. All right. And so once you have your data actually mounted in this file system, once you have your data in the file system, you're ready to do things with this. And so remember, we learned about job parallelism in the previous YouTube video. And here we're going to use that job parallelism, but just to process our data at scale. So remember, we're going to use CPUs to keep costs low. And you might use this process to, or this job parallelism framework to run a lot of data processing. So if you have, say, like 18 Parquet files, like I did when I was fine-tuning a stable diffusion with like 50 million image text pairs, as one does, then yeah, I ended up using 18 different jobs. So I had 18 SageMaker jobs where each one of them used a different Parquet file. And then on each of the jobs, they were then running multiprocessing CPU to go out to the internet, copy the images, and then download those locally and do any processing. So definitely you can use sort of this job parallelism framework on SageMaker to easily process all of your instances. Again, use CPUs for this. Do not use GPUs. It's too expensive. And then you can also use the C instance series is really nice for compute optimized. It's like perfect for data processing. So it'll run really nicely for you. The M is like a little bit too expensive. I mean, the M series is nice, but the C series is like perfect for this type of heavy compute workloads. All right, so you have your data pre-processed. Maybe you trained a tokenizer, maybe you processed the tokens, maybe you downloaded your images, you have your data pre-processed, and now we're ready to run some training. Again, I strongly recommend in SageMaker adding this new parameter, keep alive period in seconds. This is also called, again, warm pools is the name of this feature. And warm pools will literally keep your instances warm. So while you're writing your local scripts, you're doing, again, basic develop and test. You have these, forward and backward passes, this training loop that's running, and this is running on your SageMaker training instances when you want to scale it on AWS. When you add this new parameter, keep alive period in seconds, your instances actually stay warm. So your instances are just still there, even after the job finishes, up to this max time of an hour. And then after the script breaks, again, because we typed in something wrong or the syntax changed, then the instances are still there. It's just the nicest thing. And so so then you go back to your script once you realize something broke, you update your 2-3 lines of code, click go, and then it runs again on those training instances. And you're only waiting a couple seconds for your new job to run. Previously, you were waiting multiple minutes for the new job to run. Worst case scenario, you were waiting a solid 8 minutes. And even more because you'd have to wait for that first instance to actually stop, for the data to get downloaded, or the model to get uploaded if there was one. And then you're turning on the new instance. So anyway, this is much better. All right, so that's using SageMaker warm pools, right? And we'll use warm pools to develop and test. Then we're going to mount this distributed file system to SageMaker training. So we have this file system created, and we're going to pass this file system as an input to SageMaker training. So we're going to set our file system settings. So again, that file system ID, security group, the subnet, and the mount name. So you want to capture all of these things when you are creating that Lustre volume. You need to pass VPC configs as well. So to your SageMaker training job, you need to pass your VPC subnet and your security group. You need to create an S3 VPC endpoint. In order for the SageMaker training resources that are training in your VPC, for them to be able to write to S3 at the completion of the job, which they will try to do, you have to actually create an S3 endpoint from the VPC. And then this way everything can train inside of the VPC. So you create this endpoint. And then we got to update the VPC rules to ensure that there is a NAT gateway and that the ACLs and route tables are all flowing like a river. So basically you need your instances to be able to hit the internet gateway that is in your VPC by writing to the same route table. I am not a networking pro. I love my networking friends. You should too. And so, yeah, great. So then we create a data channel. And we're going to create data channels that point to, again, our training files, actually. So a training channel, so here, for example, in this little SageMaker screenshot here, we have a data channel, and we're creating two. So one is literally called train, and the other is literally called test. And so that's two data channels. In this case, they're both actually pointing to this file system ID. So they're pointing to this Lustre file system ID. I like actually passing my model as a channel. I find it a lot easier because then inside of the training script, you're going to point to those channels. Inside the training script, it actually is an environment variable. So you point inside the script to an environment variable that lets you read from the training channel and that lets you read your model. So I find it very intuitive to pass the model as a train channel in addition to obviously your training files. So you'll do that. Then you send the configs to the training job and you click run. And this is the beauty of it, is it's going to mount in seconds. So if you were not doing Lustre, if you were copying your files from S3 to SageMaker, if you have multiple hundreds of GBs, it will take hours to just sit there and copy your files. which you don't want to pay for if you're in a GPU world. So definitely Lustre is strongly preferred for that reason. All right. And then again, one word of caution here, your pro tip, please remember, so you need to hydrate your Lustre volume with the actual data. So when you create your Lustre volume in the console, that is not copying all of the data, that is just creating the metadata. So the metadata is available on Lustre the minute it's created, but you need to hydrate the Lustre volume with the actual data. So I like to run a CPU job to hit my Lustre volume that just reads, like you just read the file on Lustre, and then Lustre manages the copy. So you read it from Lustre, that manages the copy over to the volume, and use CPUs for that thing, because that's going to be a tiny fraction of the cost. Now, honestly, you can use small CPUs for that, because your CPU is literally just reading. So it can be a very inexpensive job, but just remember to hydrate that thing. All right, and so once we have our training scripts built, and we have our Lustre volume mounted to our training instances, and we have our training loop built because we were using worm pools, now we're going to run the job, and we want to monitor the performance, and we want to troubleshoot anything that's going wrong. So your training instances are up, right? And they're storing all of your metadata. So they're storing the image URI and the hyperparameters and the job configs. All that's available in the SageMaker control plane. So if you need to search for any buckets or any metrics, those are available. You can add all of the metrics that you care about to CloudWatch, actually. So in your SageMaker training instance, everything that you write to logging, everything that you print to standard outs, that will show up in CloudWatch. So you can always head over to CloudWatch to view the action, see the play-by-play, and see what's happening in your training environment. So all the metadata, again, is stored in SageMaker control plane. Once you're there, you can easily do a one-click hop over to CloudWatch and see all the logs for that instance, and it's really nice. So that's a very nice experience. And then your training instances are up. They're happy. They're running. They're storing your metadata. They're streaming your logs. And then your training instances are literally reading from and writing to your Lustre distributed file system. So your training instances, again, are connected to this Lustre volume, and you're literally reading your files, you're passing your files through mini batches, through your training loop, you're writing checkpoints, and then writing those to Lustre. Lustre then copies that out to S3 on your behalf, and then you can run TensorBoard from those checkpoints. So you can download and analyze those model artifacts from S3. So yeah, you can run TensorBoard, you can run any type of analysis frameworks or notebooks off of that to make sure that your model is trending in the right direction, that you're happy with it. A couple other things you can do. Again, view the logs. So you can go into the AWS console, click into your SageMaker training logs page, and just watch. You could look at CloudWatch and just see oh, it pip installed my requirements. Here are all of the environment variables. Here is how SageMaker executed my script. Here are all of the accelerators that it's using. It's a beautiful thing. So you can definitely view the whole process just in CloudWatch. You can read error statements in CloudWatch again. So if and when jobs fail, and fail they will, as Werner Vogels loves to say, everything fails all the time. And so, yeah, you can read the error statements. The error statements can come in from your training script. They could come in, maybe there was a GPU that went south somewhere in your training instance. And so you can read those. And then if it's an error on your side, then you can go and update your scripts, right? Point to something, reconfigure it, get it online. If it's something that's outside of your control, like an internal service error or some other unknown issue, then you can create a support ticket. So right inside of the console, you can go over to support, click create a support ticket, and then, yeah, we'll be online and we'll help you troubleshoot and figure out what's going on. Yes, and then the top question, what if my instances go down? So accelerators, GPUs, are super complex distributed systems. While a single CPU, a CPU chip is going to have like a few blocks in it. It's got like a few caches wherein it can do, sort of processing for just a few objects, like holding clicks in memory, for example. It's great at that, but it's not great at throughput. A GPU and an accelerator is useful because it's massive, right? You have tens of thousands of cores that are sitting inside of this super complex distributed system. And so the software that runs on top of an accelerator is trying to maintain those and is trying to keep them healthy and keep them active and let you run your PyTorch software or your neural network software on top of it. Using hundreds and thousands of accelerators increases the likelihood of even one of those going down. So as you scale your overall training cluster size, once you're hitting 20, 40, 60 instances, which is a couple hundred accelerators and then some, the likelihood that even one of those chips is going to break goes down. And so managed services are a nice way to get this enhanced reliability. So we run, again, GPU health checks ahead of launching the instances. So that gives you a nice way to ensure that the instances you're receiving, the GPUs are actually healthy, they're good, they're not buggy. We can replace the instances during the training process. So while the training loop is going on, we can replace those instances so that your training experience is, again, A+, and you can train this massive and awesome foundation model while getting updated instances for you. We do automatic job retries. So if you're using the training job construct in SageMaker, basically you can keep retrying. You can retry your job using this automatic job retry to get over the problem of not finding instances or to counter any instance errors. And then we strongly recommend adding model checkpoints. So in your training scripts, you can add a model checkpoint. And honestly, you can do this every couple hours and then just continue training from the checkpoint. So when a job fails, you can write a checkpoint maybe before the failure, right? Or after the failure, like in your training loop, maybe you have a try and accept, and then you try and do your forward loop. And if you can't do that, then just go write a checkpoint. And so, yeah, so then you checkpoint every few hours. And then when your job fails, the next time you try, then just point to the checkpoint and continue training from there. So then you get to save all of the work that you just did. And Lambda functions can really do a lot for you. You can really make Lambda functions your friends here. While the managed service is doing a lot, right, of the, we call undifferentiated heavy lifting, a lot of the labor to keep the service really awesome for you. The Lambda function, you can come in and layer that thing on top to monitor your jobs, to restart them on different conditions. Like if your script errors out, or if the loss does something crazy, if the data looks odd, then you can use, again, your own Lambda functions to restart the job based on different conditions. All right, so again, let's recap everything we learned here. So we talked about storing our data in S3. We talked about collecting a small set of data to analyze it with a notebook. We learned how to create a distributed file system using FSX for Lustre. We talked about sort of mounting Lustre to the SageMaker training jobs, in particular using these managed warm pools to develop a training script. Then we learned about scaling up the training runs, so hitting that 20, 40, 60 node threshold And then as always, take a look at your model artifacts and make sure they're doing the right thing. And with that, let's take a look at the demo. So you may notice that this is in fact the same notebook as the one we just saw. So in the last YouTube video, number 4 on pre-training foundation models, we learned generally how to get started with pre-training. We learned about distributed training, using model and data parallel in SageMaker, and the overall training job construct, in addition to some of the basic pieces of functionality, and we got a little bit familiar with this notebook. In this demo, we're going to use the same notebook, but we're going to modify it to use a much larger data set. So the data set we're going to use is the data set is on FSX for Lustre, and it is the web text. So the sort of canonical GPT-based data set that has quite a few hundreds of GBs. And so I'm going to walk you through how to set up FSX for Lustre and then mount that to your training instances so you can train on terabytes of data using SageMaker. So let's check this out. So just 1 second here as I get my notebook over to the right screen. All right, here we go. So FSX for Lustre is a distributed file system. And what's nice about it is that you can point it to a data repository on S3, and then it manages the reads and writes to that data repository for you. And you're going to use it for 2 reasons. The first is that it will minimize the mount time on your training jobs down to a few seconds, actually, for multiple terabytes of data. And so obviously that's a lot faster than a copy. The S3 copy is going to be extremely slow, and streamers, such as setting up a data streaming function, can be somewhat challenging to implement, particularly when you need to restart from various checkpoints and ensure the ordering of some of the batches. It's not the easiest thing, and so in many cases it's actually more straightforward to just work with Lustre, and so we'll show you how to do that today. So I'm in the AWS console. Then in the AWS console, we just picked FSX, and so there are a number of file systems that you can see, and we're going to use FSX for Lustre, which is an optimized file system for high-performance computing. So for the sake of argument here, let's try to create a file system. So we're going to create FSX for Lustre. Click Next here. And then we can give this a name. We can say my test FSX, maybe for fun. And then a couple different storage options here. These ones at the top are more high performant. The one in the middle is more low performant. We'll leave this here. And then throughput per unit of storage. If we want to max this out, let's go ahead and do that. And then storage capacity. So this is in terabytes. Let's go ahead and set this to just 1 terabyte. And then we'll leave the data compression as is. And then the virtual private cloud. So if you haven't worked with a VPC before, this is something that you may want to get some help with from your other AWS friends. VPCs are somewhat challenging, and it's helpful to work with someone who has a networking background to stand this up. But in any case, every AWS account comes with a default VPC, so you can always just use the default VPC. And then here, the wizard has selected a default, it's called a security group, and a default subnet. You're welcome to use both of those. If you need to switch your security group or your subnet, please do that now. But once Lustre has been created, we're going to copy these settings, actually, and put those in our notebook to then train in that network, actually. So Feel free to modify those, but please do just keep a note of which one you're using. The metadata for them will also be captured in the Lustre console page, so if you forget it, don't worry about it. It's easy to go catch. Optional encryption by default. And then the data repository. So here we'll say yes, we want to import data from and export data to S3. So you don't need a two-way data repository if you don't want one. I find it handy so that I can essentially load my data in S3, send this over to Lustre, and then read from Lustre during my training runs. The training runs will then write the checkpoint to Lustre, and then Lustre sends it back to S3. So then I'll just download it from S3 once it's complete. And so we can send in some S3 paths here. So for me, we'll just open up my S3 page, this account, and then we'll just pick an S3 bucket, and I'll choose my web text. That's right, so web.text. And we need to set a file system path. This is the local path on the file system that will mount our data. So we could say local mount or something like this. And then, or we could put in something a little bit more meaningful. So maybe we can say training data. And then we'll say S3, and then just the name of your bucket here. So mine is web text. And then the optional import on the metadata, go ahead and do that. So it imports the metadata. And then some of the import policies. So if we want the new metadata as the files are added, the changed and the deletes, and then the same thing on the export settings. Now again, something to keep in mind is that when we create Lustre, it will copy the metadata for this S3 path, but not the actual file. So it's going to copy the name basically and the metadata of all of the files, but not the files themselves. To copy the files over, we're going to need to do another step actually to actually move those, which we'll take a look at. All right, so then we'll say next. And then let's see if this works. So we'll try to create the file system. All right, so we have this new file system coming online, which is quite exciting. Luckily for you, I already have one set. So this is my pre-created web data in FSX for Lustre. And so you'll see a couple of these items we need. So we need this file system ID, which is great. Quite a bit of storage capacity here. And then remember, it's tracking the VPC ID, which we'll need, the subnet, and we'll also need this mount name. So all of that is stored in the metadata for the Lustre volume, which is quite handy. So now that we've configured a Lustre file system, let's mount that to our training jobs. So the notebook that we looked at in the last demo was to train a GPT-2 based model from scratch and training a 30 billion parameter model. And so now we're going to use the same notebook, but we'll add some modifications to this to mount the Lustre volume rather than pointing to S3. Now actually I'm going to be training here for you the glue synthetic data set, because that is the settings that the notebook ships with. You're welcome to modify that to use the actual web data set, which also in fact does come with this repository. So you should be somewhat familiar with this notebook if you followed the last demo. And let's just jump to the changes that we're going to make for Lustre. So first off, I am sending the synthetic data to the bucket that has the Lustre data repository. So that that bucket is web text. And then in the volume I'd already created, I actually set the path to then this data folder. So in the notebook, I tokenize the files and then load them into the S3 bucket, doing the actual copy here, and then storing the paths. And then once I've done this S3 copy, then we can actually go back to Lustre. So you can go back to this Lustre file system, and then we can click on Data Repository. So in Data Repository, and then we can take an action. So you should see this association ID that is pointing to your local file system path. So this one is fsx/data. That's the name of this local path. And then the data repository path in S3, so web-text and then data. And so what I want to do right now is move the files that I just copied into S3, move those over to FSX for Lustre. So for that, I'm going to click this association ID. I'm going to go to Actions, and I'll say Create an Import Task. And so this Create Import Task, it's going to look at this data repository path, and then it's just going to import those files. And again, it's importing the metadata for those files. So that gets imported over, and you can see we have this new task that's showing status pending because it's still in progress, and I've just completed this last task from earlier today. So the data that we processed in the notebook, first we load that up in S3, and then we moved it over to Lustre. Now that it's in Lustre, now that it's in Lustre, we can run on it. So this notebook has a few configs, so we'll set use FSX to true. Obviously not every notebook you'll interact with has this, but this one does. So use FSX, we'll set this to true, and then let's make our modifications. Great. So here, so from SageMaker inputs, we're importing this file system input, and then we're going to hydrate this with that file system ID, the security group ID, the subnet, and the base path. And that is what we want to get our hands on. So let's see if we can find the file system ID. Fortunately for us, it is sitting right here in our Lustre page, and the task has completed, which is great. So we'll look at our file system ID. So this web data is the name of the file system, but what we want is the file system ID, which is this one. So we'll copy this, and then we can paste this right here. So I'll just repaste it for you. Great. So we'll paste that in. Then let's get the subnet. So the subnet is in the network and security, and then the subnet is down here. So let's copy the subnet, and we'll put this in here. All right. And now we want to get this security group ID business. So the security group ID is not sitting in your Lustre page, unfortunately, but it is sitting in your subnet page. So let's remember that the subnet we're using ends in BE1. So we're going to click on this. This takes us out to the virtual private cloud dashboard, wherein we can see all of the details about our various subnets that, again, are created by default in every account in that default VPC. And then I'm going to click on, in this left-hand side in the security group, and in the security tab, we'll click on security groups. So here in our security groups, let's close this out here, we want to find the subnet that corresponds to, Well, actually, here. So default VPC. So this is our default VPC. So let's see if we can click on this one. All right, and then here's the security group ID. Beautiful. Great. We'll get this, and we'll paste this in. Just want to double check that this is indeed the same one. All right, beautiful. So that's the same one. So I'll just put this here. Great. So we have the file system ID, the security group ID, the subnet. The base path should be the same as that mount name. So let's get that from back on this Lustre page. Then you see this mount name here. So let's give that a copy. And then the syntax here likes to see this /. So just make sure you have this / here at the beginning of the base path. Otherwise you will get an error that says it can't normalize it. And then let's define this. And then once you have that defined, I don't think we need the VPC ID actually. Once you have that defined, the rest of the notebook should be self-explanatory actually. It, same as last time, uses the hyperparameters, and you can define your model config, define your instance count, and then create your SageMaker estimator. Now, I went through another step to create this, which is I actually built my own image, and then that image is running in ECR. Now, I did this because the VPC, in order to essentially set up SageMaker training to run nicely in a VPC, there are some extra routing steps we need to do. We need to make sure that your default VPC has an internet gateway and that the subnet we are using has a route to that internet gateway. So we need to connect those two things. And then there's another set of rules that we add to the subnet, which is like a joint inbound and outbound such that they can talk to each other, basically. And then once you've done that, you can train. We also need to create an S3 endpoint so that your training resources in the VPC can hit S3 to write your model artifacts and so on. But neither of those extra rules are going to let you install from PyPy, actually, so install new packages. And so to get around that, what I've done is created a new image and push that to ECR. So let's explore how to do that. So I'm going to go out to SageMaker. And then inside of SageMaker, I've created a notebook instance. So notebook instance. And then my image builder is running on a healthy CPU. So that's an M5.4 X large. We're going to open this up. Now you'll need to change a couple permissions with your notebook. With your notebook instance. First off, you'll need to use a notebook instance to create a new Docker image, still not supported by SageMaker Studio necessarily, and so it's handy to use a notebook instance. And then we need to give your notebook instance access to ECR, actually. So once you've created a CPU-based notebook instance and you have the IAM role, we're going to click on that, and then we're going to add some permissions to that IAM role. Really what you need in this IAM role is called EC2 container registry full access. The other ones were not strictly necessary, but the EC2 container registry really is. And so to add that, you'll go to add permissions. You're going to attach a policy. And then up here, you'll say EC2. And then if you haven't already added it, it should say EC2 container registry full access. And then that's the permissions that you want to add. I already have it, so I don't need to add it. But then you'll just click on it, for example, this, and then say add. But again, I've already done that, so I won't do this here. All right, so that's the IAM role. Then now let's take a look at the setup for this. So I like to be sort of a minimalist in creating Docker images, because that way it's just so much easier to maintain them. So the Docker container itself is ridiculously simple. It's literally a 3-line. So you're going to start in your Docker image by pointing to a pre-built, what's called AWS Deep Learning Container. Now the list of the deep learning containers is out here on GitHub. So AWS Deep Learning Containers. And then once you have your deep learning containers, go and click on for a list of all available DLC images, which is right here. And these are nice to use because they're updated extremely well. So when there are major updates to the frameworks, including PyTorch, TensorFlow, Hugging Face, etc., we'll create new images for CPU, GPU, training, and inference, and additional options, including custom accelerators. And then these should be much easier for you to get started. So let's look for the SageMaker. So these are the images that support SageMaker. And then I want the latest version of PyTorch. So I'm going to go PyTorch training, and then I want a GPU. So that's going to be this. And then you're literally going to copy and paste this. Now, if you're running in US East 1, this is the exact URL you're going to use. You're actually going to point to that AWS account to pull this image. And then you're going to push to your private AWS account. So literally, you're going to say from, and then just paste it. Now this is exactly what I have here, right? From this base image. Then I have a local requirements.txt file. So I just copy that into the container. I'm not overly concerned about where in the container. I just copy it in the container. And then I run pip install -r the requirements. So this is now in the container. Now you may see some examples pointing to setting other environment variables, setting the SageMaker program. I found most of those settings to actually slow me down and actually introduce more errors. And so this extreme minimalism seemed to limit the number of errors. So this 3-line Docker file after 5 versions ended up being quite handy. So now I have the Docker file, and then the requirements.txt. This is a straight copy from the GitHub repository. So in the Git repository, it has a requirements.txt file, which once you have this, you'll want to take it out of that source directory. Otherwise, it will try to pip install, and then you'll error out because you can't point to PyPy from your training file, from your training directory, or in training instances, rather. So, great. So take that out. And then let's look at this. So that's our requirements.txt. Nothing crazy going on there. And then let's look at what it's going to take to create this image. So again, we're on a notebook instance, we're running on a CPU, and we want to create the repository. Now, I like creating assets in the AWS console. It helps me. I'm a visual learner, so I like being able to see my assets and sort of understand where they are and what metadata is associated with them. So you can just create a repository in the console. It's quite easy to do. Just go to your ECR, Elastic Container Registry, And then we're going to say create a repository, set it to private as you like, and then say my new GPT image, or really whatever you like. And then create this, set the rest of your settings, and then just say create repository. Again, very easy to do. And it's lovely because once you have this new repository created, you can see what images have been successfully uploaded to this repository, and you can view the push command. So we're going to use these push commands to build our image locally and then push that image to the Elastic Container Registry. So that's basically what we're going to do in this notebook, with one twist. And the twist is that first we're going to log into the AWS Deep Learning Container. So the notebook, just to level you out here in terms of directories, so my notebook is one directory above. So I have this folder that's called container, and then the Docker file lives inside of this directory because the command tends to prefer a directory and not a file. So we'll send it here. So my notebook is above it, but nonetheless, so I'm going to cd into that container. And so now we're in that same directory. And then, so this login command is exactly the same from ECR, right? So we're in ECR, we're going to view the push commands, and then that is exactly the same login. But notice this is logging in to my private AWS account. The first thing I want to do is log into the AWS DLC account. So here's what we're going to do. We're going to paste, so you're going to add your exclamation mark. You're going to paste that command. Looks good. And then we're going to modify this number to point to this number, actually, because we want to log into the AWS Deep Learning Container account, which is right here. So now we're going to modify this, and this lets us log in to the AWS DLC, which we've now done. So then I'll delete that because I've already done this. And then I tend to iterate on versions quite rapidly, so I find it handy to just create a variable around this. But in any case, following those build commands, we're going to say bang, docker build, and then tag it, so -t, and then set the image name for whatever image you want to use. And then the version. Actually, I believe this should match the repository name. Let me just double check this. Yes, so the name of the image, this is the one I'm actually training on right now. The name of the image should be what you tag your local Docker file. You don't have to do that necessarily because you can still tag it later. But I like to do this right now. So you'll say bang, docker build, -t, and then the name of your repository, and then colon the name of your image, and then your space dot. And then this will pull from the AWS Deep Learning Container, again, as long as you have access to EC2 container registry, generally speaking. And if you've logged into the Deep Learning Container account, which is this one, then you can pull from that, copy in your requirements, pip install those, tag it, and you're done. Once you've built it, now we're going to log into your ECR repository. So that same login command, but this time we're logging into your private AWS account. So this one is the one I'm using. Obviously, you're going to want to paste this, change this out to point to your AWS account. And so log into your ECR account in your AWS account, and then we're going to tag that Docker image. And now again, this is just a direct copy paste from those push commands, right? So the push commands, the first one is logging in, the second is docker build -t image, and then docker tag image colon latest with that full ECR address, including the account, Docker, ECR, your region, Amazon AWS.com, GPT-image, colon latest, colon tag. So it's quite verbose, which is why the copy is handy. And so you're going to tag your local image that's already been built with this massive ECR registry name. So with this whole image name, and then you're going to do a Docker push. And so Docker push, and then that whole image is available, which is quite nice. And so you'll see all of these logs, all of this information. Then we can go back to the Elastic Container Registry and just confirm. So you can do a refresh and you should see, yes, indeed, I have a new image and I have a new version of that image. And then you can copy that image URI. And now we're going to go back to SageMaker Studio and we're going to use that to train. So now back in SageMaker Studio, we have our PyTorch estimator with all of our credentials, and we're going to add this new parameter that's called image URI, and then we're going to paste in that ECR address. So this is the full image URI that we want to paste. Then we're going to add, of course, the instance count should already be there, and then you'll need to comment out the version of Python and the framework version if you're bringing your own image. This is just due to the way the SDK checks for various conflicts. One other parameter that's quite handy to add is called warm pools. So essentially this keeps the instances warm for you so that you can develop on them very quickly. And so the parameter here is keep alive period in seconds. You can max this out at 1 hour, which I like to do. You'll need to add an extra service limit increase for warm pools. So generally, to request service limit increases, you'll go out to SageMaker, you go out to, in the AWS console, you can go to a service quota. So service quota. And then inside of service quota, you can search for different services, and then you can essentially request an increase for both SageMaker training instances and SageMaker warm pool for training instances. And so that's how you can really get get those warm pools. And then once you have that, I'm going to call estimator.fits. The data channels are passed here. Again, those are pointing to Lustre now. Again, I like to always set logs to false and wait to false. This is because I like getting my notebook back immediately. And if you have too many logs, then it will kill your notebook and it will certainly crash the kernel. So let's go out to the SageMaker console and see what's happening. All right, so let's take a look at this job. So I have quite a few jobs up and running, and in particular, I actually had to do some troubleshooting because apparently I had set up my data channels incorrectly. So let's take a look. You'll see that I was very, very actively using the warm pool feature. I'm big advocate of this feature, super helpful, super useful. Basically what this is going to let you do, and let's get a few more jobs here set. Basically what warm pools, and that's this piece here, the warm pool status, what this lets you do is very easily reuse a given resource. So when you are running jobs, for example, I've been working on this SMP GPT-2 30 billion parameter job pretty actively today, July 3rd. And essentially you run a job using this warm pool feature, and then you add that parameter, right? Keep alive period in seconds, and then the instance is still there. And so you can rapid fire ship changes to this and then the new instance comes online in seconds, actually. So it's so much faster. It really just totally changes the game for SageMaker training development because you can just fly. So it's great. And so I use the warm pull feature a lot. You can see when the job has finished and the instances are available, you'll see this little green bar, and then I can highlight this bar, and I can say actions, release the cluster, so that turns it off. So we'll release the cluster because this is finished, and then this will change to terminated. But if I had run a new job using those same instances, then it would have been set to reused, and so you see all of those reused. So let's take a look. So this last job I ran actually came after some CPU troubleshooting. So essentially, I was just not able to point to my training data, try my best. I just wasn't able to do it. So I ended up just writing a new little mini script and running some CPUs on this Lustre volume just to make sure I could actually read my data. And so I copy and pasted the config from below and then just disabled all of the distribution here and created this little mini file, load.py, which is just this. And theoretically, I knew my training data was supposed to be in this directory on the training cluster, which is optml/input. And so I just got this little walker here, so os.walk on this training directory, and then just through this list of file names, just print me the path. And so I ran this as a CPU job, again using this c5.18 with my same custom image, and obviously went through a few rounds of this to get it nice and sparkling. And yeah, and then in the logs, I was able to see, actually I had pointed to something incorrectly. So then I could go back and fix that. And really the pro tip here is just that when you're pointing to the training data, essentially when you're setting the training data as a hyperparameter, which this notebook prompts you to do, then all I was missing was the local Lustre mount name, actually. So I was just missing the name of the directory on Lustre, and everything else was fine. So then when I added it, this fsx/data, I was able to train appropriately, which was a huge relief. So once I figured that out, then I could go back and start training the actual model, which uses this estimator. So then I went back and used my image and then this much larger train.py, which we explored in the previous video in some detail with all the distribution parameters, and ran it. And so now let's poke at that thing. Okay, so here are the jobs, and here's the one I just ran. And let's validate this. So the status, a handy way you can see how long things took. So the data download, right, started at 4:37 and it ended at 4:37, right? So again, because I'm using FSX for Lustre, it's just mounting to the training instances literally in seconds. And so if you are out there trying to copy data to your training instances, and if it's taking like a half hour, you don't need to do that. Just mount to your Lustre volume and you'll be on your merry way. And so then we invoke the training image, and the process for this ran for about 8 minutes because it's a synthetic data set. Then we upload the model, and then we released the instances. And so again, the training page captures all of your metadata, including the training image. Again, running on 16 P4Ds here, pointing to FSX for Lustre with all of my relevant parameters and configs, all of my hyperparameters, and then we can view the logs. So let's take a look at those logs. So remember, the SageMaker training environment is going to give you a log stream for each of the training instances. So as many training instances as you have, that is how many log streams you will get per job. So we're going to do some clicking here. And what we want to do is we want to find the leader node. There's one primary node who's orchestrating the others, and we want to find out which one that is so that we can view those logs. As you click through these log streams, you'll see that all of them appear to be connecting to one of them. So here is this telltale. It says can connect to host algo 12. That tells you that algo 12 is unambiguously the leader node. And so now we're going to go back. We're going to go find algo 12. So algo 12 is this one. And that tells us the overall logs. And let's take this from the top. So again, when you're working in CloudWatch, we're going to do a little custom view here. So this has been running for about 15 minutes. So let me give me 30 minutes. Give us 30 minutes from this moment. It'll go back in time 30 minutes. And then great, we can see all of the reads. So first, MPI will try to just connect to all of the instances. And so because algo 12 is our sort of leader in this config, it needs to connect to all of them. And so first you'll see just this cross-node connection using MPI. So it's connecting to all the different hosts and verifying that yes, indeed, the connection is valid. And you'll see some error statements occasionally, and then it'll retry. No worries about that. Eventually we'll get all of these hosts, so all of these 16 instances. Each of them have 8 GPUs, giving us a total of 128 cards. Then, as before, SageMaker will print the training environment, so we get all of the information that we need. Somehow SMDDP was disabled through this, I think because we were using the model parallel library. And then we'll see the current host, the rest of the hosts, the instance, and the rest of the hyperparameters. So again, SageMaker will print all of this into the logs, so it's just easily viewable and verifiable. And onward ho, and then we have all of the hyperparameters, and these are the environment variables. And so you can access all of these from your training script by looking them up as environment variables. So you'll say os.environ, and then this key, and then you can look up all of these values directly from your training script. For instance groups, and then the rest of the hyperparameters, more environment variables. Obviously there's a little bit of redundancy here, but that's fine, that's healthy. And then we have all of these user args listed out again. And when it says sm-hp like that, that means it's actually custom hyperparameter. So in the script, that means we're just adding it as a hyperparameter to that hyperparameter object, and then it's showing up here, sm-hp- whatever your name is. So that's how you can add your own hyperparameters. And then here's a little bundle of the model parallel parameters. And then here is our massive script invocation. So MPI run, all of the algorithm names, the number of processes, and then all of those flags. These are the parameters that we add at the bottom. These are the environment variables that are added. You can see our script name is right here, MPI 4Pi, train.py, and so forth. And then we get the job map. So then you can see that yes, indeed, the distributed environment is able to map out all of the processes to all of our 128 accelerators. And here it's essentially copying the models appropriately and the different copies of the models using SageMaker distributed. And then we initialize the torch distributed training process using that SMDDP backend. And onward ho. And so this job will run. Basically, this is how you're going to get this. And then it's opening the different devices, which are the GPUs and the accelerators. And then the buffer manager is moving the training data through all of the model copies, managing, again, how much data they're holding in order to keep the GPU utilization stable, which basically is a fancy way of saying our model is training. So basically it's training our model, which is great. That is exactly what we want. And so this job continues, and here it completed one barrier, so it got enough gradients, and then now it's distributing those gradients out and continuing. And so in this notebook, we learned how to configure FSX for Lustre. We learned how to train on FSX for Lustre. And we also learned how to troubleshoot, because in some cases, as long as you can troubleshoot, you can do anything, but if you can't troubleshoot, you're sort of stuck. So troubleshooting with Lustre, again, just run some CPU jobs. If you like, you can also actually create a notebook instance in the same subnet as your Lustre volume and then just mount that directly. For me, I actually find it easier to just run jobs using the warm pools feature than to create it in the new subnet. But depending on your skills and backgrounds, you can just pick simply whatever you like. And so I hope you enjoyed this demo. In the next video, we're going to learn how to do reinforcement learning with human feedback on AWS. So I will see you there. Thanks.